everybody, myself Jyoti, and today we are taking second topic from wave nature of particles. So last time we have seen de Broglie hypothesis, and today we have seen four different forms of de Broglie hypothesis, and today we are going to solve some numericals based on that. So let us see this first problem. Find the de Broglie wavelength of a baseball of mass 2.5 kg having velocity of 10 meter per second. So what is given in the problem? Velocity is given. So we have lambda equals to h by p. We know that momentum it is given by m into v. So we will use this form as there is velocity which is given in the problem. We know that Planck's constant is 6.63 into 10 raised to minus 34. Mass of baseball it is 2.5 and its velocity is 10 meter per second, which is not comparable with the velocity of light. So you can keep it as 2.5, and then if you will calculate, you should get 2.64 into 10 raised to minus 35. Check if you are getting that. So second problem is, what is the accelerating potential required to accelerate an electron from rest so that its de Broglie wavelength becomes 1 angstrom? So we have lambda equals to h by p and h equals to root of 2 m0e. So how we get this? P equals to mv, p square equals to m square v square. So I can divide by 2, multiply by 2, and I can write m as m square as m into m. So I can write this as 2 by 2 m v square into m. So 2 and half mv square is e, and this m. So I'm getting p square equals to 2me. That means p equals to root of 2me. This is how I have got this. Okay. So I have lambda equals to h by p, and whenever energy is given, so h equals to root of 2m0e. Now here what we are talking about in the numerical is when a charged particle it is accelerated through a potential. So we know that when a charged particle it is accelerated through a potential v, it gains energy that is given by E equals to qv. And here we are talking about the charged particle electron. So that charge we can replace by E. That means instead of Q you can write E. So here the energy which is gained by the particle, it is E equals to small e into V. So we have this E into V. For E we can write E into V. Then take square of both sides. So you will get lambda square equals to h square upon 2m0ev. And as you have to calculate capital V, shift this v to this side. So we will get v equals to h square upon 2m0e lambda square. And after that you just substitute the values which are given in the problem. And after substituting you should get v equals to 151 volt. Try it yourself, do the calculations and check whether you are getting the same answer. Now let us come to problem 3. What is the de Broglie wavelength associated with a proton moving with a velocity equal to 1 by 30th of the velocity of light? So we have velocity of proton which is equals to 1 by 30 into velocity of light. So just substitute the value of velocity of light, that is 3 into 10 raised to 8, and you will get around this 10 raised to 7 meter per second. Now lambda equals to h by p equals to h upon mv. As velocity is given, we will use this form, lambda equals to h upon mv. Just substitute the values. Very simple problem, and check whether you are getting this answer. Okay. Now fourth problem, at absolute temperature T, the energy of a particle is of the order of kT, where K is Boltzmann constant and its value is 8.6 into 10 raised to minus 5 electron volt per degree. Find the de Broglie wavelength associated with a neutron at 27 degrees Celsius. Now again we have to use this form because we are talking about energy. So we will use lambda equals to h upon root 2me, this form. Now as per the given condition, what is given in the problem? Energy value, it is equals to kT. So we will replace this E by kT. So E equals to kT. So I have lambda equals to h upon root 2m kT. And then we will substitute the values of 2, m, k and t. H is Planck's constant, that value you very well know, upon 2m. What is m? Here check which is the particle. They are talking about neutron, and mass of neutron it is 1.67 into 10 raised to minus 27 kg. So you will have to substitute that value. And then K, Boltzmann constant, it is given in electron volt. 8.6 into 10 raised to minus 5, that is electron volt. First thing you will have to do is to convert it in joules. So conversion factor is multiply it by 1.6 into 10 raised to minus 19. That is how you can see this term extra, 1.6 into 10 raised to minus 19. I am multiplying 8.6 into 10 raised to minus 5 with 1.6 into 10 raised to minus 19, so that it gets converted into joule. That is the conversion factor, and multiplied by the temperature. 27 degree, that is equals to 27 plus 273 Kelvin. So I'm getting 300 Kelvin. So temperature, you have to convert it in kelvins. Boltzmann constant, you have to convert it in joules. And value of m, that is mass of neutron, it is 1.67 into 10 raised to minus 27. That value you should know. Okay, so when you will substitute all these values, try it out, and you should get wavelength around this 1.777 angstrom. Check whether you are getting the same answer. Thank you so much.